Okay, so this problem says to use resistance reduction and source transformation to find Vx in this circuit, and all resistance values are in ohms. So one thing that I see when I see this problem is that a clue that you would use source transformation is that you have your source is a current source, and that current source is in parallel with some resistors, and when you have a current source in parallel with resistors, then you can use source transformation. Now you want to be careful, and you want to be careful not to mess up the thing that you're trying to find. So we're trying to find the voltage across that 4 ohm resistor. So I don't want to transform that, because if I transform that, then it'd be difficult to find the voltage across it. Now I can find, if I'm trying to find the voltage across something, I can always find the voltage across something that's parallel to it, and I would get the same answer. But in this case, there is nothing parallel to the Vx. And y'all see how there's nothing parallel to it? So for the first thing I'm going to do is some simplification that I can do that won't change this Vx. And I see that right here, I have 2 resistors in parallel, and right here I have 2 resistors in parallel. Now, these two 16 ohm resistors are in parallel, but they're not in parallel with the 12 ohm resistor because of this 4 ohm resistor up here. Now, a little shortcut you can take is if you ever have 2 resistors in parallel that are the same resistance, so let's say both of these are A, then the equivalent resistance to both of those in parallel is A over 2, it's half. And so that's what you would get if you did product over sum. You would get half, and you can see that with the formula. You could prove it. But in a test situation, if you have 2 resistors in parallel that are identical, don't waste time. Just say, oh, okay, well that's equivalent to an 8 ohm resistor right there. So I'm going to draw that. So these two 16 ohm resistors are equivalent to an 8 ohm resistor, and I'll leave this middle part alone for now, 10 amps and 6 ohms. Now I want to be careful when I get over here that I want to check, ask myself, am I going to mess things up by combining these? Is that going to mess with my voltage over here? And the answer is no, it's not, because these two are in parallel. Things that are in parallel have the same voltage. And so when I combine them to one thing that's equivalent, it will also have the same voltage. And voltage is the thing I'm looking for right here. So I'm in good shape here. I can combine those two and turn that into an 8 ohm resistor. Okay, so now I see that my 8 and 4 ohm resistor are in series. And since those are in series, I can combine them just by adding them together. And looking ahead, I see, hey, 8 plus 4 is 12. That's going to make me a 12 ohm resistor in parallel with another 12 ohm resistor, which I like. So, but I'll just go ahead and draw it out. I'll do it step by step. So that's 8. That's 12, that's 12, this was 10 amps, that was 6, this was 4. Okay, now, the 4 ohm resistor and the 8 ohm resistor are in series, so I could combine those, but I don't want to, because they will not have the same voltage if they're in series, and I need the voltage across that 4 ohm resistor, so I don't want to do that. The two 12 ohm resistors, however, I can. And what will that equivalent resistance be? 6. Okay, now I see that I have two 6 ohm resistors in parallel. Now, you might not see that they're in parallel because you'd say, well, what about that current source in between them? It doesn't matter because the current source is also in parallel. They're all three in parallel, and so it doesn't matter what order we put them in. We can like shift them all around. If they're in parallel, they're in parallel. It doesn't, their actual position doesn't matter. So this 6 ohm resistor and this 6 ohm resistor. Okay, this is just a heads up. I'm about to make a mistake in this video where I divide 6 by 2 and get 6, and then the rest of the problem will be wrong after that, but then I go back and I'll have the correct solution after that. So just warning on that. Are in parallel, so I can combine them to a 3 ohm resistor. Am I crazy? Is there no longer an eraser up here in my drawing tools? I don't think I'm crazy. Do y'all see one? There it is. Okay. Okay, so now my next step is going to be a source transformation, because now I have a resistor and a current source in parallel. And a resistor and a current source in parallel can be transformed to a voltage source and a resistor in series. And usually those are they're easier for me to deal with. And so I just use V equals IR to get what the equivalent voltage will be, and the resistor stays the same. And so this will become a voltage source that is 60 volts, and it will be oriented with the polarity with the positive terminal up, because the arrow on the current source is pointing up. So it will have that will be the same. And then I have a 6 ohm resistor, and then I have my 4 ohm resistor, which is the resistor that I'm looking at, and 8. Okay, and I'm supposed to be finding the voltage across this resistor, and it was labeled plus minus. Okay, so now I have a circuit where everything is in series. When everything is in series, that means I just have one current. And so my current is running through this in this direction. And since I have that, and because my current is running through the resistor in the way that it's drawn, it's going into the positive side and coming out of the minus side, that means that it is in the correct orientation for me to say that V equals IR for that resistor. So the V that I'm looking for my problem will be whatever my current is times 4 ohms. Now I can find what my current is by saying, let me imagine the equivalent circuit with the equivalent resistance that I have here. So I'm going to draw this circuit with a 60 volt voltage source and an 18 ohm resistor. Now this has the same current running through it as this one does. Now I can't use it to answer my question about the problem because it doesn't have the 4 ohm resistor anymore, but whatever current I get here is the same value as the current here. So V equals IR, or 60 equals I times 18. Did y'all see any mistake that I've made? Because I would have... No? Okay. Because I'm really bad about making math errors. So I equals 60 divided by 18. Let's see, that's 10 over 3. 3.333. Okay, so I equals 3.33, And so V equals 3.33 amps times 4 ohms, which would be 13.33 volts. And that would be our answer. Now let me check it and see how many mistakes I made, because that's what I do. This was problem 336. That's not 336. It was 236. Although 336 looks like a good mesh problem. So I might do that one next. Okay, my solutions end at 35. Okay, yeah, so I will assume for now that I had it right, and I will check it later, and if I made a mistake, I'll post a correction. So as promised, I did make mistakes. I very cleverly took two 6 ohm resistors in parallel and said two identical resistors in parallel will be equivalent to a resistor that has half the value, and half of 6 is not. In fact, 6, half of 6 is 3. So let's change that one. So this should have been 3, and let's see where that takes us from here. Okay, so now that would give us instead a 30 volt voltage source, and then we would have 30 equals I, and now our equivalent resistance is not 18 because it's 3 plus 4 plus 8, so that's 15 ohms. So this would be 30 over 15, which is 2. So I is 2 amps, and then that means that the voltage across our resistor right here, V equals 2 times 4, V equals 8 volts.